All right, so we've seen a ton of functions so far. We've seen the combined function, class, filter, dim, GLM, all these good things. Well, it turns out you can write your own functions. So it's good to be able to cut down on things that you're doing over and over again. So it's easier to fix things if you have a problem. You can use functions to organize code into manageable pieces. You can avoid running code unintentionally. So something that's outside of a function, can just be run by accident. And you can use names for functions that make sense to you, right? So you could name a function whatever you want, and maybe it's exactly what it's doing. So something like, dim maybe stands for dimensions, but maybe like that's not easy for you to remember. So using names that make sense to you is a nice thing about writing your own. Okay, so let's just get into it. So how do we write our own function? So we can use function to do that. And we'll want to create a function here that multiplies some number that's provided by 2. So that stand-in, right, this x is a stand-in for, whatever number you're going to supply in the future. It's inside the parentheses here. And then after this, you tell it, what exactly you want it to do. Okay, so it's a little bit different from what we've seen before. And then you'll use the assignment to give the function a name. Okay, and so how do we actually apply this? So we'll take the name of the function and the stand-in, that variable that I gave it, and then actually provide a value for it. Okay, so let's see that in practice. So we'll do times, oops, wrong window. Times 2 is a function of x that does x times 2. Okay? And then if I want to do times 2, x equals 10, I should get 20. If I want to do 100, I should get 200, and so on and so on. Okay? I can call this x whatever I want. It can be variable. And then I have to say, oh, okay, well, this is what I want you to do. I want you to take variable and multiply it by 2. And then I'd have to specify variable as my argument name down here. Okay, so that's our function kind of in a nutshell, how that's shaped. Okay, well, what if we have a function that's doing a couple different things, right? It's not all going to fit on one line after this function x. We can use curly brackets. So that allows us to span multiple lines. And so if I wanted to kind of modify what I've got over here, I could do function variable, add in curly brackets, and by default R gives you both sides just so you don't forget the other side. I'll hit enter, and I'll put the meat of my function inside those brackets. So let me move this up here and get rid of this. Okay, so it works just the same way. So running all of that, getting the times 2 where variable equals 100, looks good. Okay, doesn't really change what's going on, but if I had to do other things down here, I'd have the space to do it. If we want something specific for the function to give us, we can use the return function down at the bottom. So let's say I'm doing some computations and I have multiple steps, multiple outputs. I could say, okay, well, I'm going to give it some, I'm going to do some computation here, and the output will be this object called output. And I want to return that anytime I run this function. I just tell it, oh, I want to return output. That's what I want you to give me. Okay. Should do the same exact thing. Okay, so as you're writing your own functions and they're getting a little bit more complicated and more detailed and interesting, the general syntax for function is your name for the function has been assigned by function, and then some number of inputs. You can call them whatever you want. Then the body of the function, the meat of the function, what's it doing with those inputs? And then returning some value. Okay, this return part is going to be consistent throughout functions. Okay, so functions can take multiple inputs. So let's say I have a function that I want to do times 2 and then plus some value. I can give it the x and the y input, and I can say, oh, well, I want that to be x times 2 plus whatever I supply for y. And then when I actually apply that function, I have to give it both arguments, right? So if I go back and I say, well, all right, my function times 2 plus y is a function of x and y, and it takes x times, oops, I got to make sure I use the right case, plus y. Goes ahead and puts it in memory. Plus y, x is 10, right? But if I don't supply y, it's saying, you didn't supply that. You told me there was an input y up here, but I didn't get it. So got to make sure we supply everything that we use in the meat of our function and as our inputs that are specified. Okay, so y could be 5, and we'll get some output there. Okay, so maybe you'll find, you're using the same input over and over again, or you just don't want to have to specify it all the time. Functions can have default arguments. So this lets you use the function without using an argument later. So let's say I want to, by default, x is 10 or y is 3 if I don't give it those values. So if I go over here and I say, okay, well, by default, I want x to be 1 and y to be 1 also, or 0 maybe. And then I go down here and I'm like, oh, well, I'm just not going to specify. And I run those. It doesn't actually need me to specify because it has a default. Okay. And those defaults can be whatever you think is appropriate. Okay, so let's practice. Let's write a function, sqdiff, that takes two numbers, x and y, with default values of 2 and 3. It takes the difference, squares the difference, and returns the final value. Okay. So let's practice. So if we're going to name it sqdiff, we'll give it function. It's going to take two arguments, x and y, with default values of 2 and 3. I'm assuming those are in that order. Let me use my curly brackets. I'll put everything down here. So we're going to take the difference. So x minus y. I'm assuming that's what we want to do. And we want to square it. So let's put that in parentheses to make sure we follow our order of operations. So let's square it using the caret. And we'll save that as my value. and then we'll return value. Okay. So I think that should cover everything. So let's test it out down here, and we'll run everything. Okay, so by default, it's taking 2 minus 3, so -1, and then squared is 1. Okay, so that makes sense. But if I were to supply it, x equals 4 and y equals 1, right? The difference would be 3, squared is 9. Okay. Okay, so we could have made it a little easier on ourselves and just had that on one line because it was a pretty small function. Okay, and as we've seen a few times, you don't actually need the x equals part. You can just say 10 comma 5, but I think in general, when you can specify the argument name, I think that's really good practice because somebody else looking at this might not know that the order is important. Okay, because the order sometimes is important in functions. So I like to say, you know, x equals, y equals, even though it kind of assumes that order. Okay, so functions can have any kind of input. We can also make a function with a character type. So let's say we have a function where we provide some word, and that word gets plugged into the toUpper function, and then that gets repeated 5 times. And so that's saved as a vector called output, and we'll just return that output. And so I called this function loud. It's doing toUpper, it's repeating, and it's taking this argument or this variable word, and that is a stand-in right there. So when I actually run the function, I just use the name loud and I specify this word argument, and it turns this all into upper and repeats it 5 times. Okay, so just like with numeric, any kind of input can be used in a function. Okay, so let's do a little bit more complicated stuff. So let's say we're working with a data set cars, and I think I already have this in memory. Yep. Okay, and so maybe we want to develop a function that is called getRow, and it takes it is a function that takes 2 variables here, two arguments. One is dat, which is our data set right here, and one is the row number that I'm going to specify. Okay, and so let's see kind of how that will play out. So we'll make a function called getRow of dat and row. I'm going to supply both of those. I'm going to pipe that dat here into filter, and I'm going to ask for row number equals a certain value that I supply. Okay. Okay. Let's run that, and then I supply get row of cars and let's say I want, I'm kind of looking at it, let's say I want this line right here that has the Kia. I want line 7. Okay, so yeah, that pulls out what I expected. Okay, so maybe you want to use filter and select to pull out an index. So this is, I know we had some questions about this, but let's say I want to create a function called getIndex where I'm providing arguments for data, the data set, the particular row that I want and the particular column that I want. It's the same function as before, but I'm piping that into select a column. So let me add a column argument here, no default, and then piping this into select and some call number, okay? So row is equal to 7, and I'm still hung up on this Kia thing. 1, 2, 3, 4, 5, 6, 7. I want column 7 as well. Okay. All right. So that's a way I can get, and probably I should have renamed this something more practical, such as get index. Boom, I can pull out the particular cell of the data set that I want. Okay, and just like before, I can provide default arguments. So, let's say I want, by default, it's going to pull out row 1 and column 1. I can provide that, or I can do that without specifying those arguments. But because I don't have a default data set specified up here, I do still need to provide that argument. So I do need to tell it I want dat to be cars. All right, so what kind of cool things can we do now that we've created our own functions, and what in general can I do with these? And so these are just some, the following slides are kind of showing us how we can actually iterate and do a little bit of saving ourselves a little bit of time by actually applying functions. So we can basically apply functions to many things at once with sapply, simple apply. And so these functions take the form sapply, and you're giving it some kind of list or things you want to, a vector of things you want to perform some function on. And then you just provide the function name. Okay, and so probably an example will make this a little bit more clear what I'm talking about. So let's say I have my cars data set and I've got tons of columns. And I want to basically go through all of those column names, and I want to get the class for every single column. I can do sapply. And I say, I want you to look at the cars data set, and I want you to apply the function class. And so normally class has parentheses, right? Because it's a function. But in this case, this is a very special case, I do not use parentheses. All right, so it's telling me, it's going through iteratively and saying, okay, ref ID is numeric, is bad buy is numeric, purchase date is character. It's going through all of them one at a time and kind of figuring that out. Okay, and so maybe another example is we want to pull out a specific column from data, and we want to perform some action on it. So maybe we want to pull out, let's see, so costs could be cars, and we'll pipe that into pull, and I think it was vehicle B, yep, vehicle B cost. So what does that look like? We've got this object costs now. I think this is in dollars, I would guess. Man, inflation really is a bummer. And so let's pipe that into sapply. And we'll say, okay, well, I want to do some function to costs, and I want to multiply that by 2 plus some value y, this kind of function that I put together up here. Okay. And let me fix it because it's not actually doing what I said. So let me or actually, that's fine. So yeah, still multiplying by 2 and adding y. Okay. So we'll just tell it, okay, well, I want to use this function. And what does that give us? Okay, so it's taking this particular function and it's applying it to every single item in costs. And so you see these numbers are a little bit bigger now. They're multiplied by 2, and I believe it's adding, by default, it's not adding anything because y is 0. Okay. Okay, I do want to, actually, we'll get to that. Hold tight. So the nice thing is if we, don't have a custom function ready to go, we can actually do them on the fly using sapply. So let's say I don't have a function that does what I want yet, but I have costs and I want to divide them all by 100 or 1,000 or something like that. I can say, oh, okay, I'm just going to put my function right smack dab here. So we'll do function of x and then say, okay, well, I want x divided by 1,000. And it does it for us. So this can be kind of nice if you're like, oh, well, I don't know what I want to do until kind of the last second. So this is really useful for modifying columns and things like that in your data sets. And I'll show you a little bit more about how that works. Okay, so we have that, but there's a function called across from dplyr that makes it really easy to, and we talked a little bit about this already, but it makes it really easy to apply some function or transformation to multiple columns. And so we usually use that with like summarize or something like that. And so the way across works is very similar to sapply. You provide the content you want it to go across. And so this is a number of columns that you list out. And then the second thing you provide is some function. Okay. So this calls argument is the columns. This FNS funds argument is the function you want to use. And then list out, this is kind of confusing, but you're going to list out any additional arguments for the function. Okay. Because not all functions just take everything by default. So what do I mean by that? So let's think about our cars data set. We'll select a couple of columns here to kind of go forward. And so what does this look like? It's make and model, and then it's mostly just like the numeric columns here for where is the double precision type. Okay, so I'm taking cars double. I'm going to group by make. So what's the brand of the car? And then summarize across everything. And then across everything, I want the mean, right? So it's going to find the mean for me of all the columns grouped by make. Okay. And so if we look at the data to start, see I have like multiple lines for Dodge and for all, Ford and other brands and things like that. But it's going to say, okay, well, let's find the mean cost within make. We'll find the mean odometer reading, all that good stuff. Okay, so this is what I was talking about when you're including additional arguments. So we're taking this data set, we're grouping by make, we're summarizing across columns, we're applying this mean function to get the mean of all of those columns per make. But as we know by now, the mean has this argument na.rm equals true, right? We want to get rid of those NAs to calculate the mean. And it doesn't look like it's a big problem for our data set, but all we have to do is supply that argument after the function that we specify. Okay. All right, and just another flavor of this, we could take our data set of numeric columns, group by make, summarize across columns, and we can pick the columns that start with vehicle and apply this function mean. Okay, so that's just kind of limiting the number of columns from this previous example. Okay, these tidy selects are super handy. All right, so we could combine across and mutate to basically do some manipulation of columns. Okay, so what we can do is take mutate and then do across inside and tell it, you know, I still want to work on these columns that start with V as in vehicle. I want to apply the round function, and I want to get to the nearest like 1000. Okay, so this digits is an argument that I could provide to the round function. So if I were to kind of queue up round, it's asking me, you know, how many digits do you want to round to? Okay. So when I run that, instead of having vehicle cost be to the nearest dollar, now see it's to the nearest 1000, right? And vehicle age is to 0, right? Because that's the nearest 1000. So maybe it doesn't make the most sense, but maybe for odometer, right? But in general, this is nice if I want to kind of apply an adjustment to multiple columns, such as, you know, I want to replace some character in all of my columns with another one. So I could say, okay, well, I want to go across all my columns. I want to use the function string replace all that we talked about in data cleaning. And I'm saying, okay, well, I want to find any instance of uppercase A, and I want to replace it with lowercase a across all of my columns. And I want to replace them in place. So you can see now I have lowercase a's everywhere, right? And it doesn't matter what column I was referring to, it kind of did it everywhere. Okay, and this is also really handy when it comes to replacing NAs. So let's say I'm looking at this mortality data again, and I'm reading that in, I'm renaming country. This one had kind of a funky name, as we remember from the lab. But let's say I want to select, I'm just cleaning this up a little bit, making it easier to look at. I'm going to select country that starts with country and any columns that start with like it are in the 1940s, so start with 194. And let's say I want to mutate across columns 1943 through 1945. And for those, I want to apply the function replace NA, and I want to replace NAs with zeros. Okay, but I only want to do it on those columns. So you can see down here, I still have some NAs for those other years, but for these, I was able to apply across 3 columns without having to kind of list it out every time. Okay, so very nice way to apply functions to your columns. All right, let's summarize this. So very exciting. We can create our own functions. They take the form of the new function name is assigned. And then you use function of whatever those inputs are, and then you specify what's actually happening to the right. And you can use those curly brackets. If you need to break lines, you can specify defaults by taking the inside of these parentheses and adding some default values. So the default of x is 1, the default of y is 2. You can apply your functions with sapply by giving it some contents and applying some function, and that doesn't have parentheses on that function, it's just the name of it. And then finally, you can use across to apply functions across multiple columns of data, and notably across works really well with like your tidy data that we've been working and thinking a lot about.